Look at this simulation here. I have a wave going along, so you can see I got a wave going along. Travels along. This is a transverse wave, as you guys should know. You'll notice it moves along kind of slow. Okay. Well, if I change this thing up here, so I go like this, and I go like this, you can see that, hey, I changed the medium. And now if I have my wave go along, hey, it goes along really fast, because the only way to change the wave speed is to change the medium, which hopefully you guys remember that. But now really what I want to talk about is what happens to the wave that gets transmitted, and then what happens to the wave that gets reflected if it does change mediums. So let's say I am going to go from a fast wave to a slow wave. What is this like? This would be like light going from air to water. Okay, because light travels faster in air than water. But if I hit run, you'll see that you can see the wave slows down. So if you can look at just this part, the wave slowing down. The transmitted pulse, you see, keeps going along like this. So it keeps going in phase. Okay, and we'll talk about that. Hopefully you should know what that means, but it keeps going in phase. Where the reflected pulse, it comes back out of phase. This is sometimes called a hard reflection. Why is it a hard reflection? Because this end is acting like a fixed end. It should make sense because it's going from a light medium to a heavy medium. It bounces back on the opposite side. So the transmitted pulse is in phase. The reflected pulse is out of phase. So I mean that should make sense. And this is a hard reflection. Okay. If I was to reverse it, so I'm going to go from a heavy medium to a light medium. This would be like light going from water to light going to air. So the wave's going to speed up, and you can see that. Goes slow, slow, slow. Oh, goes fast. Okay. And you can see, number one, okay, the transmitted pulse is in phase. That wave just keeps going. And the reflected pulse is also in phase. It comes back on the same side. This is what's called a soft reflection. Why? Because this boundary is acting like a soft boundary. It's a free end. It's free to move. So with this one, transmitted pulse in phase, okay, and reflected pulse out of phase. Or sorry, in phase as well. So reflected pulse in phase, transmitted pulse in phase. All right. Bye, kids.